As we go on to topic 8.2, we're going to use what is called the quadratic formula. Now, so far when we have had a quadratic equation in standard form, we would factor it if we could. We also used in the previous section completing the square, so we could use the principle of square root. And this is reviewed in example 1. If you have x squared equals something, then what you do is you take the square root of this and then plus or minus the square root of that. So x then would equal plus or minus the square root of k. Well, if you had standard form and you started to complete the square by taking the c term over to the other side, and then taking half of b and going through the whole procedure, and eventually if you were to solve for the letter x, you would get that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. And the key to using the quadratic formula is first to put whatever you have in standard form. Once it's in standard form, you want to define what A is, what B is, and what C is, and then through careful substitution into your formula, then work it and you'll get a results. Notice there is a plus and minus sort of built into the system here because of this. And let's see how it works. So they want us to solve this equation. And again, we have to identify what is A. Well, in this case, A is going to be 1, B is 3, and C is negative 2. So let's start to fill it in. So x equals a negative b, so that's going to be a negative 3, plus or minus now the square root of b squared, which is going to be 3 squared. It's a negative, well, it's a positive 3 here, but this term always ends up positive because if it's a negative something squared, it'll become a positive. If it's a positive something squared, it will stay positive. Okay. Minus 4. A we see is 1. And C is a negative 2. And then all over 2a. 2 times 1 is 2. Okay. So we have substituted using our A, B, and C from standard form, putting it into the quadratic formula. And now it's a matter of calculation. And this will be 9. Now a negative 4 times a negative 2 is a positive 8. So 8 plus 9 is 17. So I'll just put the 17 there. And that's all going to be over 2. And actually that's your answer. Now often you have to write it twice. Negative 3 plus the square root of 7 over 2, negative 3 minus the square root of 17 over 2. Going on to number 4. As you look at it, you might say, well, what's wrong here? Well, is it in standard form? And the answer is no. So the key to these is that they have to be in standard form so you can properly identify the A, the B, and the C in standard form. So let's rewrite it. 4a squared. I'm going to transpose this, negative 32a, and transpose that to a positive 20 equals 0. Now, again, we'll identify the A as 4, the B as a negative 32, and see over here, if you thought that was the B, no. B, when it's in standard form, is a negative 32, and our C term is a positive 20. So then you substitute into the quadratic formula, x equals, now notice, B is a negative 32. So we would have to write that minus a negative 32. So can you see here that this value is going to become positive? Because it's the opposite of a negative would make this a positive. And then plus or minus the square root. And we're going to have to square 32. It's actually a negative 32. You can do it this way, but it's going to become a positive. Plus 4a, which is 4, and c, which is 20. And then that's all over 2a, which will be 2 times 4, 8. Now here, it's just a matter of, using your calculator. I would suggest you figure this out. This is going to be 16 times 20. This is going to be plus that squared. That gives you what you have under the radical. You may have to simplify it. There may be a perfect square in there. And again, that's sort of tedious. And eventually you're going to put your answer over 8. And I can see over here that when this 32 is over 8, this is going to become a 4. And then whatever this becomes, it'll be plus or minus. And I have it worked out here. It ends up becoming plus or minus the square root of 11. Now there might have been an 8 out here that canceled with the 8. And again, this is going to become a 4. I'm not going to work all these out for you, but I wanted to show you how to integrate your quadratic formula with the standard form of the quadratic equation and then grind it out. Some of these can be quite tedious, but again, whether you're going to use factoring, completing the square and then principle of square root, or the quadratic formula, it all works out the same. And this one is a general multi-purpose. It can be used for any of them. All right, let's do a few more to give you the flavor of what this is all about. So there's your quadratic formula. And they are directing us to solve these by using the quadratic formula. Now for number 6, I rearranged this to put it in standard form. So again, we could identify the A, the B, and the C. Here, we're going to have to work on this, and so are we going to have to work on that one. So putting this into the quadratic formula, we're going to get T equals a negative B. So B is negative 4, so the opposite makes it a positive 4, plus or minus the square root of b squared, which will be 16, minus 4 times a, which is 1, times c, which is 11, all over 2a. So, once again, 4 plus or minus. Now, this becomes a 44, a negative 44, and a 16. So this is going to be 8, and this is going to be 2. So this gives me then a negative 28 under the radical sign, divided by 2a. Now as we look at negative 28, remember that's like a negative 4 times the square root of 7. Now what did we say negative 4 under the radical sign was? Well, that was going to be 2i, that's what negative 4 is, the square root of 7, and this is going to be over 2, as we said. So watch what happens. We're going to put this over 2, this over 2, so this now becomes 2 plus or minus I, the square root of 7. Now remember, you can also put the I at the end. Again, this is standard form for the imaginary number. All right, for this one, takes us back to, I believe, chapter 6, where we have fractions, and we have to multiply every term by the lowest common denominator, which happens to be x squared. So here the x squares cancel out. We end up with a 1 minus 2x squared equals, here one of the x's cancel out, and you end up with 8x. So to put this in standard form, I'll put the 0 over here, bring this over as 2x squared. I have a plus 8x, bring the 1 over as a negative 1. And then there I have now, there's my A, there's my B, and there's my C. You need to put it in the quadratic formula. For number 8, again, we have to clear parentheses. This is going to be 4s plus s squared minus 3s equals 1. Again, we have to identify our A, B, and C, so we have to put it in standard form. S squared, when we subtract this, we end up with a positive s, and a negative 1 equals 0. And it never hurts to check your work. So 4s, s squared minus 3, yep, that looks good. Putting it in order, subtracting these two, get that, bring that over, yes. So again, your A is 1, your B happens to be 1, and your C is 1. So again, putting it into your quadratic formula, that should do the trick. And again, I'll finish this one up. We have A is 1, B is 1, C as a negative 1. So I put it in the quadratic formula. There's my B is 1, so negative B is negative 1. Plus or minus 1 squared is 1. minus 4a, which is 1, times c, which is a negative 1. This gives me a positive 4 plus 1, positive 5, and 2 times a is 2. So this was actually a little easy. Again, we're showing you technique where you had to clear the parentheses, put it in standard form, so you can identify the a, b, and c. Okay? Again, if I did them all, it would take a lot of time. We just want to be sure we can identify our a, b, and c to put it in the standard form of the quadratic formula. Okay, I've put up a few more examples, and rather than go through the tedious part of writing them out as I went along, number 13 I put in standard form of the quadratic equation, where I had to identify a, which is 1, b then is a negative 6, and c is a positive 25. Then I went into the quadratic formula. B is a negative 6, so we're looking for a negative b, so it's the opposite sign of a negative 6, a positive 6. Then we squared a negative 6 and got 36, minus 4 times a, which is 1, times 25, which is c, all over 2a, which is 2. So this part stayed the same, and I put it over 2. And then this became a negative 100, and I added 36 to it. I ended up with a negative 64. Now the square root of a negative 64 is a negative 8i, and I divided that by 2. So this cancels out and gives me a 3. Plus or minus, this cancels out and it gives me a 4i. Oh, there's no negative there. Would have been a bonus point if you caught me on that. All right. So the negative is part of the 8i. Okay, so there's the answer. Now for number 14, I put that one up because that's sort of interesting as well. Here it's the difference of perfect cubes that equals 0. So I had to factor that into its factors. Now, again, this equals 0. So then I equal this factor to 0 and this factor to 0. Now this just ended up as a, x here is a 5. So that's one root for this. But I need 2 more. So when I put this into the quadratic formula, a is 1, b is 5, c is 25. So again, b is a positive 5, so it goes into the quadratic formula as a negative b, so a negative 5. Plus or minus b squared, which is 25, minus 4 times 1, which is a, 25, which is c. This gave me a negative 100, plus 25 gives me a negative 75. Now, I divided a negative 75 into 2 parts. The square root of negative 1, and then in a sense the square root of 25 times 3. The square root of 25 is 5, and there's my I, the square root of 3. So here are my 2 answers. A negative 5 plus this over 2, negative 5 minus this over 2. For number 17, they wanted us to use a calculator to approximate the two answers to 3 decimal places. So I put it into the quadratic equation, solved it, and I don't need to go through all the steps with you. This is something you'll have to work on, and you need to try to get them right. Over here, the square root of 24, it remembers the square root of 4 times the square root of 6. Square root of 4 is 2, this 2. And then here, these cancel out. So I get x is negative 1 plus the square root of 6. It's also negative 1 minus the square root of 6. And then I went in with my trusty calculator here. And I guess it comes in pretty good here. Well, I don't know. Have any light here? And I put this into the calculator, hit enter, and that's one value, which is positive. And I use the approximate sign. And then here's the other value, which is this. Now actually, the TI-83s have a program that you just put in, A, B, and C. And I have a Casio that does the same thing, and it'll give me these answers. So I'm not sure what the teacher wants you to do, work through this to get this, or whether you're just going to be able to use a calculator to get that. Okay, I think that about does it. Yep. Because now we're going to go on to topic 8.3. We have a little time today.